intersection number is defined by, well, the intersection pairing of these classes. Well, the intersection pairing evaluated in these classes. And where does it live? So now we are working with homology of with the Z pi coefficients, so that's why it lives in Z pi. This is why I had to mention this, because we actually we work with the homology of the universal cover or of a oriented regular cover with Z pi coefficients. Well, Z pi is Z pi 1 and so I mean sometimes I will say pi instead of pi 1 m. This is yeah, it's just shorter. But I mean for this talk it's always pi is always pi 1 of m. I mean you can do it a bit more generally. You don't have to look at the universal cover here. You can look at another cover, but it must be somehow consistent with the orientation situation on M, and you will still need somehow that this will make a strip. But for us, pi is always pi 1 of M. This is a homology class, and the push forward is still a homology class. But what I mean is the dual. So the Poincare dual of this. So A cap A to the n cap CP to n. So this is now a class in. This is Poincare dual of A to the n. And well, the homology intersection pairing is just the cohomology intersection pairing if I pass from homology to cohomology via Poincare duality. So I can, instead of looking at the homology pairing, I can look at the cohomology pairing. So I take the duals and evaluate them at the fundamental class. Well, I mean, what else should it be? These are dual classes, so it's just one. Okay, questions so far?
Sorry, could you explain why that algebraic intersection is Taiwan?
Say it again, please. That the algebraic intersection, that it's here, because we're working with that pi 1 and coefficients. In fact, so. So the homology of M here, cohomology. This is the homology of single chain complex or of the universal cover. And what is this? I mean, this is Z by 1. Does it make sense? Z by 1 module chain complex, but I mean, this doesn't answer the question. Wait a minute, something is wrong. I need a tilde for the x, but then I can't define this via this. I mean, if you start with the CW complex, yeah, so you have cells, and now you can lift the cells, and for every cell you get actually for every cell you get pi 1 copies of the cell on the universal cover. Yeah? So what actually happens in the universal cover is you get Z pi 1 cells. This is just, I mean, I'm not sure about the notation now, but it somehow does this make sense?
So when you define algebraic intersection, you're basically thinking about lifting the universal cover.
Yes, I always work on the universal cover. I mean, don't have to do this. I could define the intersection just by looking at the situation here instead of M tilde, and then it would be a number. But the situation is more complicated, and I want to make statements about homology with Z pi 1 coefficients. It's homology of the universal cover with Z pi 1 coefficients. And that's why I need an intersection number, which actually lives here. I mean, this is the usual number, but yeah. And now bigger coefficients, and of course h naught, where this is evaluated, is just one copy of the coefficients. Yeah, so it's one copy of z pi 1. Yeah. Okay.